last topic is this idea of, you guys answered kind of, you had some great answers about why people maybe study astrology. Okay, study astrology. Well, yeah, study your horoscope. Had some great answers there. And your horoscope, of course, are actually correspond to whatever your sign of the zodiac corresponds to. Where'd my stool go? Where'd the sun go? Oh my gosh. Oh, thank you. There's the sun. So the signs of the zodiac actually correspond to constellations of stars. So the way this works is that this is the sun. Thank you. The sun is returned. As the Earth orbits, how long does it take the Earth to go around the sun? 365 and a quarter days. Yeah. So as the Earth does this, right now, as I'm over here, the nighttime, we're going to see these constellations, right? Okay. So 6 months, and by the way, I can't see constellations over there, right? But I will tell you, and if you look at this diagram, I'll kind of say how this works. Those constellations over there we can't see, that's the month that you get your zodiac sign from. So I am a Sagittarius, okay? So in December, the Sagittarius is hiding behind the sun, basically, okay? So then I go over here 6 months later, okay? And now I can't see those constellations because the sun, they're kind of behind the sun, but I do see these constellations. So if you look at the different constellations that we would see, they actually lie in the plane of the ecliptic. So the plane of the ecliptic is, a plane of course just needs 3 points to kind of, the plane is flat, okay, plane is flat. And I call it a frisbee. So this whole frisbee thing on which the Earth orbits the sun and the other planets orbit the sun, this is called the plane of the ecliptic. This is the plane of the ecliptic. So if you extend the plane of the ecliptic out, that's where you're going to see your zodiac constellations. Okay. So on that map that I gave you for September, if you, do I have mine? Let's see if I can find mine. They always put, well, yeah, on the map I gave you, they always put the plane of the ecliptic. And it's on this map, it's a dot, 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 dot. This one for, well, this one's for August, but that should work. So you see the Milky Way, and can you find the plane of the ecliptic? Yep. Does the plane of the ecliptic, does it go, it's kind of short, isn't it? The plane of the ecliptic. But that's where you're going to see, or this is the ecliptic. This is the line. This is like, if we look into here, this is the slice that the Earth orbits the sun in, okay? By the way, this is also the slice, since the other planets orbit the Earth, you know what I mean? Since the other planets orbit the sun in the same slice, this is where we're going to see our planets too. So just looking at this, you're like, whoa, I see Saturn, I see Jupiter. Where are they? They're on this ecliptic line. So that's kind of how that works. So bless you. What I started to say is, if you're like me, I know somebody that is all of these type, except for, where'd it go? This guy, Ophiuchus. I don't know an Ophiuchus, okay? So now don't blame me. There's actually, instead of 12, there are actually 13 constellations that the sun appears to pass through as the Earth orbits the sun, okay? So I know, and you're like, that's not my sign. I know, it's okay. You still are your sign, okay? But if you're like me, this changed my world, okay? Instead of being a Sagittarius, I'm an Ophiuchus, which I know doesn't even make sense because astrology doesn't have an Ophiuchus. But the sun really does pass through Ophiuchus. Okay? It kind of blows that one off. Why? I'm not sure. Have to ask an astrology person. Okay? So now I bet you really have cemented, hopefully, kind of what the plane of the ecliptic is. This is a good diagram. Plane of the ecliptic. All the planets orbit the sun in this plane. And I think your question was, how does that compare with the celestial sphere equator? Well, the celestial sphere equator, actually, remember, it's that imaginary ball, and I think we're going to see that imaginary ball again today. It's that imaginary ball with the Earth in the center, and how do you get the equator? You extend out the Earth's equator onto the celestial sphere. And actually, they are related. There's a figure that in your textbook that shows how it's related actually to the ecliptic. They're tilted 23.5 degrees. There's a lot of things in astronomy that hurt my brain, and that's one of them. So this will be due again today. That's great. Or just hand it in with your other stuff on Friday. On Friday, we have a picnic. Yay! So be sure to not blow that off. Okay, so let's go on to the next part. Talk about seasons. Did I hear a yay? All right. By the way, I was kind of wanting to know how we were doing time-wise since I've got a whole new textbook I'm lecturing from this semester. Waited to when the first exam is, and I don't think I told you guys. I'll put it up here. But tentatively, Unit 1 exam, tentatively is September 20th. Now that is tentative. Okay, so we'll just see if we get there or not. The neat thing about this semester is you're the only section I have, so you're the only one I have to keep up with. That's kind of fun. All right. So we talked a little bit about this the other day, and I didn't bring in a globe. So sorry about that. But we know we can take the Earth and kind of chop it up. We can chop up, you guys told me what latitude is the North Pole? No. That's the equator 0. So what equator 0 latitude, the pole is 90, yep. 90 north, 90 south, exactly. And we kind of get these kind of great circles that go up north and that go down south, okay? Now, lines of longitude actually, and I kind of remember somebody saying, well, why do they start in, why is the prime meridian that start in Greenwich, London, England? And I don't know why. Okay, I still don't have an answer to that question. But if you would picture the globe, you guys are looking at Greenwich, that's the prime meridian. Now this is lines of longitude that go this way. Okay, then you have to go, let's see, which, is this east or west, you guys? It goes east west. Okay, if I go west this way, lines of longitude, I go east this way, lines of longitude. Okay, this is 0 longitude, this is west, and this is east. And then they meet again back behind at the international date line. That's so cool. Okay, where a day, it's a day's difference. It's so weird. I cannot imagine. I'm just going to have to go one of these days. So we have lines of latitude relative to the equator, and we have lines of longitude that are relative east or west and east relative to the prime meridian. And they meet back around here. Do you guys remember what's the biggest line of longitude you get then as you go around? Nope, this is lines of longitude. So this is going, so we're at, I don't even know what we are, longitude. I know latitude we're about 42, but you go, this would be 90 degrees longitude, and then this would be
180.
180, yep. They go all the way 180 west, 180 east, and they meet back here at the international date line. That's how they do it. This then is that where this would be 0 degrees, okay? 0 degrees longitude. And so you go this way, you're starting west longitude. You go this way, you're starting east longitude. And I should know this. We are west longitude. Yes, okay. Okay. How fun is that? There is the international date line where they meet up about 180. So it bumps up with 180 degrees west, 180 degrees east. They bump up here. All right. See the plane of the ecliptic, right? See the Earth going around the sun. See the Earth's tilted axis of rotation. That is still here. That's good. Okay. What angle is it tilted from being perpendicular? What's that angle?
23.5.
23.5, exactly. And actually the way I tilted it is on purpose, because what direction is that ish? North. Yep, that way's north. And so that way is south. And so that way is east. Yep, and that way is west. Sometimes I'm like, I don't know, different ways to think about it, but I kind of think now, if I've been here in the evening, where does the sun appear to set? I'm like, oh, that way. That way. Okay. So what you're seeing up there actually is here, and we actually have a date for here. A date for here is June 21st. Okay. So I'm going to go, let's see, how many months do I need to get here? 3 months. Very good. So what date is this? September 21st-ish. Yep, coming up. I say ish because I can never remember if it's like between 20 or the 23rd, so I say 21st-ish. So on the test, as long as you get the month and the day-ish, you're in good shape. Okay. All right, so 3 months later, you told me that was September. What's this? September? Okay, yeah, what is this? December 21st-ish. Yeah. Okay, 3 months later? March 21st-ish. Yep. Yep. And here we are back here again to June. So this, we have 2 solstices. The solstices are our extremes. So does it kind of look like the north axis of rotation is tilted towards the sun? I'm glad we found the sun again. Okay, does it look like it's tilted? Yeah. And it's not, and so this is summer here, right? This is the middle of summer. Now there's a lag, and it's a meteorological sort of thing. There's a lag between when our hottest days are and when our most intense sun rays are, just because of the Earth's oceans and the water and everything. But this actually is when the Earth, in the northern hemisphere anyway, is getting the most intense rays. What season is it in the southern hemisphere here?
Winter.
It is winter. Yes, very good. So, perfect. So here, 6 months later, what is this solstice called on that slide? Winter solstice. Yes, this is the winter solstice. This is the other extreme, and you can see the northern axis of rotation tilted away. The southern axis of rotation is tilted towards the sun. And that has consequences with regard to kind of how direct the sun's rays are. We're also going to kind of convince ourselves that also has consequences, this kind of configuration, as to how many days of sunlight that area gets. When we are here in December, how would you, relatively speaking, say our daylight hours are? That's short. I meant to say December. If we're here in December, the winter solstice, how many daylight hours do we get, relatively speaking? Not as many. Well, it kind of depends on your latitude, but our daylight hours are fewer. Our daylight hours are fewer. That's why people have seasonal affective disorder, because they don't get the sun rays. Okay. So those are our solstices. What is this? What does that slide say this is? This is March 20, no, this is not March. This is September 21st-ish coming up. What does it say? Because autumnal equinox. I want to make sure I was consistent with how they do it. Autumnal equinox. It's autumn. Equinox, actually, I'm going to try to convince you how this works, but here at the equinoxes, whether it's the autumnal equinox or the vernal equinox, which is spring, okay? At the equinoxes, as the Earth spins, actually all places on the Earth get about equal amount of hours of daylight and nighttime. That's kind of where the equinox comes. Okay, so this is one of our 2 equinoxes. And of course, you guys told me this is the winter solstice. Then over here, we have the vernal or the spring equinox. If you're like, I don't like the word vernal, which I don't like the word vernal, I just say spring equinox. So feel free to borrow that from me. Okay, so that's kind of the season sort of thing. But you guys told me when we're experiencing summer, the southern hemisphere is in the middle of their winter. Okay, here they would be coming out of their winter. They're in spring, we're in fall. Okay, over here, we're in winter, they're in summer. Okay, over here, we're in spring, they're in fall. So as the Earth orbits the sun, the angle of the sun's rays onto different latitudes of the Earth changes. So here we have how kind of straight up and down, and no, it's not straight up and down, it's not perpendicular, but in the summer, I'll put it this way, let me go back to the summer. In the summer, have you guys noticed that it seems like the sun climbs higher in the sky? Remember we said your local side, you can actually you feel kind of strange, but you can put out one arm for your horizon, and you can put the other arm where the sun is, and you can see what that angle is, okay? In the summer, we have a big angle, okay? In the winter, if we go out even at noontime when the sun's highest in the sky, the sun is kind of, it's not as big of an angle at noon as it is in the summertime. Okay, and that has consequences. It looks like this. So for instance, if you have this shaft of light, it is spreading over an area. We'll kind of just assume like it's a circle shaft of light coming from the sun. The area it's spreading over is 1.04 square meters. That's in the summertime. In the wintertime, when even at noon the sun's pretty low, we can go ahead and do that little crocodile looking thing, get an angle. It's pretty low. Okay, now that same shaft of light has to spread over, how would you compare these two? Look at the area. What do you think? Talking maybe twice the area? The same shaft of light, just because of the angle, it's called beam spreading. It actually just has to spread out over a larger area of the Earth's surface. And then because of that, it's kind of has a dilution sort of thing going on. Okay? So
it's not as intense.
What's that? Yeah, it's not as intense, exactly. Because that same amount of light, it has to go over a larger area. This same phenomenon, I mean, not to confuse anybody, but oh my gosh, even like throughout the course of a day, you see the sun rise with a small angle, noon, the largest angle, and then set with a small angle. We have the same phenomenon going on in a day's time. It's cooler, it's cooler in the morning, hottest at noon, or most intense rays, and then, as the sun sets, those rays are diluted like this. Not diluted, diluted. So, yeah. So, I put together this little this kind of summarizes what we just talked about. We talked about our important days, and notice I said 21st-ish, right? You can coin the term. Okay, we have two solstices. We have the winter solstice in December. We have the summer solstice in June. Okay, and then we have two equinoxes. We have the vernal or spring equinox in March, and we have the autumnal equinox in September. So somewhere in there, you're going to want to know those dates-ish. Okay? So, and I've got some slides to from OpenStack's textbook to kind of reinforce this, but, oh darn it, I can't believe I forgot oh, by the way, can I erase this? Did you guys see, like if I grade your stuff, if you see a check mark, that means it's perfect. I know it's kind of backwards from what some teachers do. Check mark, it's perfect, just kind of squiggle through it, means that there was something not quite right about it, and I probably commented it, and if you see an X, it means, yes.
On the autumn equinox, so how come is it the 22nd and 23rd instead of 21st and 22nd like all the other ones?
Oh, that's a good question.
Just because?
Honestly, I think this slide is more right than my 21st-ish.
Okay.
That's a good question. Yeah. So, there are some, I'm going to try to draw a globe of the Earth, and I'm going to put the equator on there, and I'm going to put the poles on there, and I'm going to draw two more lines in each hemisphere. If I can find a marker. Okay. So this is my equator. I'll put equator. So what latitude is that? 0. Yep. And then I'll go ahead and put my North Pole, my South Pole. So what latitude is the North Pole? 90. And this is 90 degrees south. Cool. Well, we have two more important markings, and they both, in both hemispheres, I'll go ahead and make this a solid line. I'm going to do a dash, 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 dash. The first important line of latitude actually happens in both hemispheres at 23.5 degrees. This is north, and this is called the Tropic of, what is it?
Cancer.
Cancer. You're right, Cancer. I always think of the other one is like you get corns on your feet. I'm going to go ahead and do another one down here. 23.5 degrees south, and I'm going to make that the Tropic of what?
Capricorn.
Capricorn. Cool. Then I'm going to go ahead up here and 66 1/3 degrees north, and I'm going to call that the Arctic Circle. Arctic Circle. You might have heard of the Arctic Circle before. You're kind of like, well, that's just a general sort of vague thing. No, that's really a place on the Earth, the Arctic Circle. Yep. And I'm going to go down here. Don't want to leave the southern hemisphere out. And I'm going to make this 66 1/3 degrees south latitude. And we're going to call this the Antarctic Circle. Where's Antarctica? Down south. Antarctica is a continent right down here. So Antarctic Circle, Antarctica.
No polar bears.
Polar bears?
None.
Oh, there aren't any?
No.
Okay.
Only in the north.
Oh. Good. So I mentioned that because I have a column here that says if you are north of the Arctic Circle, okay, what can you expect with regard to the number of daylight hours? Remember, we get daytime and nighttime as the Earth spins on its axis of rotation. And the way it works is, again, I'm going to show you this diagram coming up, but at the winter solstice, okay, if you are north of 66 1/3 degrees north latitude, if you're up here, as the Earth spins, basically, you still don't see the light from the sun because of how you're tilted. Okay? There's like been movies, can you imagine? This is like, I think only one movie, maybe? I don't know, about vampires. Vampires moving here because, yeah. Anyway. So that's how that works. Now,
when I was stationed in Germany up near the North Sea, we would get like 4 hours of nighttime, and it was because we were so far up north. And you'd like go to the club and you take a break outside.
Right.
And you go, dang, I missed nighttime.
There are definitely issues. What Barry's talking about is if you're over here, okay, what time of year is this, did I say?
This is autumn.
Nope,
Or,
summer.
Oh, summer.
This is summer, yeah, this is summer. If you're over here because of how it's tilted, and you are, like this says, north of the Arctic Circle, check out how many daylight hours you have. The sun doesn't set. You're like, are you serious? I'm like, I'm serious. Just because of how it's tilted, the Earth spins, okay? And the closer you are to 66 1/3 degrees north latitude, the longer your days are, which just means you have more daylight hours.
I mean, if you're up in Alaska, that's what.
Right, Alaska. And it's like you can hear people have issues with their, it's a biology thing, what's circadian rhythm? It's a crazy thing. This actually is trying to kind of prove to you that in the land where the sun does not set, okay, here you go. This is actually just images taken of where the sun is throughout the course of a period of 24 hours. It does not set. Now, what did I say equinoxes mean? Equal what? Equal daylight hours everywhere. Daylight hours equal to nighttime hours, so you can look at it a lot of different ways. So you would figure, you know, if you're north of the, I keep on saying Mason-Dixon line, but if you're north of the Arctic Circle, okay, you're still going to get 12 hours at the equinoxes. So we already said, and I think you probably kind of figured, if we're experiencing summer, then the southern hemisphere is experiencing winter. And so we kind of have this sort of mirror sort of thing going on with regard to the Antarctic Circle. We can kind of say pretty much everything the opposite. Okay? In the winter solstice, 24 hours of daylight south of the Arctic Circle. The summer solstice, we get 24 hours daylight north of the, that I should have said Antarctic. We get 24 hours daylight north of the Arctic Circle, 0 hours daylight south of the Antarctic Circle. So anyway, I hope that helps. So here's some figures from your textbook, and you can already kind of see these divisions. These divisions in this figure correspond to these divisions that I wrote here. Okay, so you see the equator, okay, see the Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle. So those are things you probably want to kind of get a handle on. So we are on the summer solstice for the northern hemisphere anyway. The most direct light, and I don't know if you can tell it or not, but let's see. See if I can write on this. I think I can. Oops, go back. Bless you. We say the most direct sunlight on June 21st, okay, in the northern hemisphere is at the Tropic of Cancer. So what did I say? That was 23.5 degrees north. So this is actually who's getting the most direct light. Okay, these guys are at a slant, and these guys are at a slant. But can you kind of see how, if this is our winter, summer, this is our summer solstice, see if you are south, I like this diagram, because you see if, as you are down here, as the earth spins, you're not going to see the sun at all. Darkness. Hello, darkness, my old friend. And then up here, as the earth spins, you're going to see the sun all the time. Okay. Changed up a little bit. So you can see that this is actually December 21st. So this is what, over here. So we have our equator, Tropic of Capricorn, Tropic of Cancer, and our two circles, Arctic Circle and Antarctic Circle. So do you see where, actually I'll go ahead and mark it on here, but the rays are most direct here at the Tropic of Capricorn. This is 23.5 degrees south, most direct. And then again, you can kind of see the extremes related to the Arctic circles. Here, these guys are going to see 24 hours of daylight. Here, these guys are going to see 24 hours of nighttime. So what is this kind of ghosty looking thing around the Earth? What's that? Not the atmosphere. Celestial globe. Yep. Celestial sphere. Yep. The atmosphere is real. This is not real. But it kind of works to kind of think of those stars as being printed on the celestial sphere, celestial globe. Very good. So again, kind of like the homework question that you guys answered today. But can you see where this red line says ecliptic? Okay. And this right here is the celestial equator. Okay. The ecliptic, again, is the plane that all the planets orbit the sun in. Okay. And don't think about it too much because it's true. But the celestial equator, if we take Earth's equator and extend it onto the celestial sphere, there's actually a tilt between those two, 23.5 degrees. That makes sense. So these will be due, there's quite a few of them, but I think they're okay. Notice that 210 kind of is related to the question you were answering today a little bit. It says, explain what's so unique about those constellations we call signs of the zodiac, okay? And then, again, you have some questions for chapter 4. So actually, I'm going to ease on into, we're going to begin the slides for the next part, okay?
On our sheet that you gave us, it says that we only have to choose 3.
Oh, thank you. Oh, that saves me greeting. Thanks for pointing that out. So what she's saying is the sheet I gave you, and we're sticking with the sheet, is what does it say? Just choose 3 of all of these?
Yeah, this is choose 3.
Score. Thank you for pointing that out. Yeah, I need to put that on my slides. Choose only 3. But feel free to answer more if you want. But okay. So let's just kind of, it's all interesting. One of the things I like about astronomy is I don't have to work too hard, I don't feel like, to sell it. But with that said, history, I don't know. The older I get, the more I appreciate history. So maybe it's an old person thing. Now, I went ahead and I skipped a slide. So if you printed off the slides, you're going to see the slide that was next. Actually, you're going to see that on Friday. But in the meantime, I just want to kind of look at why people would care about stuff, like stuff going on in the daytime sky. I am amazed at people, eons ago who didn't really know what we know about science today and would go ahead and conjecture what was happening. Another thing I think is awesome when I think about the especially the nighttime sky with the constellations, how people used to sit and look each other in the eye, and they'd actually talk about patterns in the sky. When I have when youth come out to the observatory, sometimes they'll say, "Well, I see and they'll fill in the blank of what they see in the nighttime sky." But they used to tell stories about it and everything. But these are kind of practical things. I mean, it's a practical thing to know what time of day it is. Okay, it's a practical thing to know what time of year it is. And there are ways, of course, of knowing those things when you look at where the sun is. Tracking the cycles of the moon can kind of tell you how your weeks are going. Observing the planets and the stars. And it was a navigational tool, too. One of the things about I would say not just astronomy, but one of the things about the wealth of knowledge that we know and love here today, actually, one of the cool things about science is that we don't reinvent the wheel, that we build on what other scientists have said. And we went through, what was it, the Dark Ages, I want to say? Yeah, I know. Where actually there was a blundering, knowledge was evil. But prior to that, actually, this is the Library of Alexandria in the Middle East, where knowledge was actually kind of sought out prior to that the knowledge is evil thing. So, and a lot of that did good. So this is actually in Nigeria. They would actually look to see how the crescent moon was tipped to understand the months. Anybody been here before? No, me neither. Bucket list.
They have one that's at the Berry Hill Museum in Oregon.
In Oregon?
Yeah,
Like a recreation of it?
Yeah.
So as I understand it, that these stones, which it's uncertain how those stones could get configured how they are, but actually they are a way of understanding where the Earth is as it orbits the sun. And actually in the solstices, there are some, I call them sweet things that happen in these stones. How the light hits or comes through these stones. So, look cool. It's got a very old structure.
So that was the whole purpose that they built those for that reason?
That wasn't the purpose, but it kind of goes back to it honored it for the people who built it. It honored the seasons. So, and probably it was, I'm guessing, like a meeting place and a part of their spiritual journeys. So, yeah. A big old sun tower. Oh, yeah. Oh, it didn't make it. Oh, no, it's on the next slide. So I mentioned kind of the sweet spot. This kind of blows my mind. I think there are more of these sun daggers, but this is just a picture of a sun dagger where at noon on the summer solstice, okay, the sun goes through this slit and hits the bullseye in this sun dagger. Okay, and again, this structure wasn't built just to honor the seasons, but this structure built by this Machu Picchu, what civilization was that? Is it Aztecs maybe? No. We should ask Mr. Thank you, yeah, Mr. Evans. Okay. But again, they built it knowing where the sun's sweet parts are. You know what I'm saying? It was a big, hairy deal. This actually is we said you can use Polaris, right, to kind of know what direction north is. But this is similar. You could use it to match these knobs up to stars to get your bearings. Okay? And then I kind of wanted to leave you with this idea. Now, I've not ever been to, anybody been to Manhattan before? Okay. But the other thing this has to do with is Neil deGrasse Tyson was the guy I heard this from first. So on the summer solstice, Manhattan's got the whole buildings going on. On the summer solstice, yes, the sun lines up between those two buildings just like that. So anyway, I think that's cool. Well, that does it for today. So we'll pick up here on Friday.
It's probably not exactly that.